Thank you very much. I've been asked to explain some of the experiences of HARBEC and how we, over the last 15 to 20 years, have pursued sustainability in our manufacturing business. First of all, what is sustainability and why bother even? The EPA describes it as creating manufactured products through economically sound practices and minimizing negative impact while conserving energy and natural resources. That's an important point, as you'll see in a minute. The key benefits then in this conserving resources kind of thought is, again by EPA, lower resources and product costs, lower regulatory compliance costs, improved sales and brand recognition, greater access to financing and capital, and easier employee hiring and retention. Basically, all of those are about the fact that it is resourceful, that you are using less. And as an example, then that's kind of what drove HARBEC into the curiosity about this potential. And so when we started in that direction, the first thing that we had to do was to overcome the truth that wasn't true, or the normal way of thinking, which was that being green is nice, but you can't afford it. And I don't know how many times you've heard that, but it is still today a very, very common response when you talk about it. So we needed to understand that better and basically set out to disprove it, because it didn't, when you started looking into it, made less and less sense. We also needed to remember as we're doing that the number one concern is corporate social responsibility is the corporation. We had to do it in a way that made the corporation still be stronger and financially equitable, or there would be no more corporation to do it. And the other responsibility for us, or the carbon responsibility, or that developed as we were looking into resourcefulness and to environmental awareness and responsibility for what we were doing, a term came out, an awareness developed along the same path of time, which was called carbon, and carbon reality and carbon awareness, and we wanted to be a carbon responsible company, a carbon responsible manufacturing company. But in the U.S., unfortunately, that's not very, there's no government at this time behind it. The government is in fact ignoring it. But we still got the exposure from it from the other 26 countries that we send products to. So we continued our pursuit whether the government was interested or not. As carbon responsibility goes, examples in the world beyond the United States are, for example, European commodities market claims that by the year 2020 they will be largest commodity traded on the European commodity market will be carbon. And the Asians, China specifically, are now last year predicted that they will beat Europe to that goal. And another example beyond one country or another is the Walmart Sustainability Index label, which in the near future will be on all the packages in Walmart, and will have a second label that says the amount of responsibility, so carbon, water, and all the other attributes that went into making it, along with the flour, wheat, and sugar contents, and the fat and carbs and all of those. So a Walmart store does it, then all big box stores will do it, and those stores are the same in other countries as they are in the United States. So as a product producer, we see in the future an awareness of carbon at the consumer level, and we want to be part of that, and we want to use it as a marketing strategy and a thing to help our business be even stronger. As an example, then, in this pursuit of responsibility for how we run our company, this is a slide taken from our annual company meeting where we report how we did and taking care of our responsibilities. And you'll notice in there things like the purge, regrind, recycle, 202,000 pounds, but that's up 3 times from what it was when we reported the same thing last year. 21,000 pounds of resin reused, not sent to the landfill. And of course, that was the first. Also, the big thing is recycling is a form of recycling. So we're not putting it in the landfill, we're reusing it. This one, 21,500 pounds, is up 10,000. This includes plastic wrappers and plastic bags. We also recycle our metal, up 2,000. Our wind turbine, one of them, the 850 large one, produced twice as much renewable energy as it did the year before, and on of examples of how we measure ourselves constantly to make sure that we're making progress in the right direction. And the last one there, our cars driven, that's our one of our carbon uses that we haven't got a complete solution for, and so you'll see how we take care of that. Specifically by buying carbon credits. And in the U.S., where there is no carbon tax, the only responsible thing that people can do is at an individual level by buying offsets. In many countries, the carbon tax is built into the product or the service that you buy. But here, because we don't have that, things are less expensive, but we also allow unlimited dumping into the atmosphere at no charge. So as an example of numbers in one company, 614 tons of CO2 were produced by our company. And that represents the amount of natural gas that runs our microturbines and the amount of fuel that ran our vehicles. And even though we have alt-fuel vehicles and electric vehicles, we still have some fuel that's consumed, and we need to take responsibility for that by buying carbon credits. And so this calculations show you, but the big thing is that 614 tons of purchase offsets and 2,300, almost 400 total tons means that 1,771 tons is not being produced because of our renewable energy and the renewable energy that we buy from the grid. So, why ISO 50001 SEP? What does that mean? That is a new ISO standard, International Standards Organization, that is a world standard that was initiated by the U.S. Department of Energy. So it's a standard that simplified means you will, if you follow this standard, produce or use less energy per widget forever. So you will be always, for the rest of time, reducing the amount of energy that goes into making said object. There are two flavors of this standard, and the first one is certified. The second is SEP, or Superior Energy Performance. To me, the certified one is a result of good wordsmanship. So if you follow the examples and have all of the things described that are asked for, you will be able to get certified. But there's no checking on that. So it's strictly basically an honor system, I suppose, that may or may not be an effective way to improve. But the second way is definitely effective because you allow yourself to be third-party audited. That third-party audit, to me, is the validation. I can say all kinds of things, but it's what I do that makes the difference. And so for HARBEC, the SEP was exactly what we needed because we would have a third-party audit of our carbon. And if we had that as a validator, we then could go to the marketplace and present ourselves as a carbon-neutral company. And again, remembering what I mentioned a minute ago, because we want to figure out a way to use this as a marketing strategy, as a way to improve and sell our company and improve our bottom line. So ISO 50001 SEP, we became certified in 2013, and in October of 2014, we reduced our usage by more than 20% from a baseline that was established in 2009. As SEP ratings go, that's a platinum rating, and according to the DOE, HARBEC continues to have the fifth highest reduction of all companies who are ISO 50001 SEP in the world. Energy reduction has saved HARBEC a minimum of $85,000, which was on this slide before, just in energy for the past year, which is a positive improvement on our bottom line just for that year's efforts alone. So why bother? As an example, $85,000 that I just referred to at a rate of 5% margin, which is typical for small manufacturing companies, 5 to 10% margin, would be comparable to the same way, let's say, to put that amount of $85,000 on the bottom line would be to go out and get $1.6 million of new work, do all the work, and then have the typical 5% margin at the end. So it's a great positive way to make a positive impact on the bottom line that's real and impactful. The current HARBEC energy management strategy is made up of three basic pieces. First, our combined heat and power plant, which reduces the cost through energy efficiency. So we are using the energy more completely, which you will see as an example by using the other 65 to 75% that the utility model, the current utility model, throws away or wastes. Renewable energy on-site generation, there we are fixing energy costs for 25 years into the future because there are no fuel costs attached. With non-renewable energy, no matter whether it's coal, oil, natural gas, or nuclear, you know only one thing, that the price will escalate. And the reason why is because the fuel costs escalate. And so all you know for sure is that you're going to be paying more money, and ours is fixed because there is no fuel cost. So you ask yourself, where we can't do it through our on-site generator ourselves, there's a second option that's almost equally impactful to the environment, which is when we buy our power, we buy all green power. In doing that, by making that decision, we are forcing the utility to do what we want, which is to go to the marketplace and buy green energy. So they have no choice. By law, they have to do it. And so we're, in the sake of the environment, accomplishing the same thing as if we put the wind turbine outside ourselves. The difference is that one's a cost and one's an advantage, as you're going to see in the very near future. So just a quick recap of the last 15 years that have brought us to this point. In the very beginning, we had a lot of problems, and one of the biggest problems was myself. I didn't realize it, but initially when I started out, I was running on passion and personal conviction, and I realized after a few months of failure with that I was inadvertently branding myself as a burned-out hippie or a Birkenstocker, but certainly not a serious businessman. And so rejection after rejection from the banks, I needed to rethink what I was doing. And I did, and came back 6 months later with the same projects, the same possibilities, but never ever again mentioning the word environmental or green or my children's future or anything else that I might dare to be concerned about. But only numbers, only dollars and cents. And the result of that change of presentation made the difference, and we began to start to do projects. So the first thing that we did, we put up a combined heat and power plant that was supposed to be a hybrid, combined heat and power and wind. But in those days, there was a lot of fictitious technical information flying around about microturbines. They were just coming into the marketplace. People were making some unsubstantiated claims, and unfortunately, we used fictitious numbers to get our bank loan so that when we went to order the machines and they wouldn't sell them to us, we didn't have the same economics that we promised the bank. When we did find a company who could produce them, as a result of that, we were over budget. We went back to the bank with the help of NYSERDA and were able to secure the combined heat and power portion of the project first. And then after that was complete, about almost 2 years later, we went back to the bank with the completed numbers. It showed how well it was working, and they allowed us to borrow the money to do the wind turbine. So it was disjointed, but by the end of 2002 and early in 2003, we finally put the wind turbine portion of the project together. Then in 2007, we did a lighting upgrade. This was before LEDs. So it was, you'll see the numbers, why it was economically advantageous. So for all of these things, we did in 2008, our CHP project paid off. What does that mean? When I say paid off, and I'm going to be saying it over and over again in here, I mean that instead of sending the payment for however much energy they made to the utility, I took that payment and sent it to the bank. And I paid off the payments with the energy money that I didn't spend. So, as an example then, in 2000 to 2008, in 8 years or less, actually a couple months less than 8 years, we paid off the combined heat and power plant that still is running today, that will run for many years into the future, by just taking our energy dollars and spending them in a different way. We also did a barrel insulation project, which I'll talk about. Our wind turbine, our first wind turbine paid off in 2010. Again, using the energy dollars, instead of paying them to the utility to buy electrons, I paid them to the bank to make electrons. And then in 2012 or 13, because the other turbine had paid off 2 years ago and kept giving me about 300,000 kilowatt hours a year of free energy at that point, I decided to try to do it again. And so our second wind turbine went up in end of 2012, early 2013. And then 2013-14, now the LED technology is getting stronger and stronger, and people are guaranteeing their products. So we did a whole lighting project all over again. And then recently in 2015-16, we were given an opportunity by NYSERDA to do a CHP upgrade. And I'll be explaining all of these things to you and showing the economic advantages or the eco-economic advantages of doing them. And then we are, as good ISO 50001 SCP people, we have all kinds of things waiting for us in the future. We're always thinking of ways to keep improving it and striving for that less energy per widget forever. And you can see a list of a few of those, and I'll talk a little bit more about them later. So to describe these different elements, first our original combined heat and power plant. It consisted of 25 natural gas-fired 30 kilowatt microturbine generators. It gave us a total of 750 kilowatts of potential. Our peak demand on average is usually no greater than 500 kilowatts, which meant we could safely have a 250 kilowatt redundancy for backup and for maintenance and for growth and expansion in the future. Combined heat and power is all about the thermal advantage. So really what we're doing by generating on-site, we're doing the same thing a utility is. We're burning fuel to make electricity. But the difference is that the utility throws away 65 or 75% in the form of thermal energy as they pump it into the lakes and rivers, and we use that energy. And in using it, we are displacing the need to use other electric or gas energies to heat and air conditioning and to fill thermally related needs. As examples, if you notice in the schematic version of this, we have 4 turbines, and we're taking the exhaust gas, so you can see that down here, and we're delivering it to a heat exchanger, which is a tortuous path of baffles inside of a very highly insulated box. And as the exhaust gas is forced through the tortuous path, there is tubing running through the baffles with water running through the tubing. And so what we're doing in those boxes is creating a constant supply of 200 to 220 degree hot water that we take out to do other jobs with. So you can imagine, I mentioned earlier about the tubes in the floor. That's a very easy way to take that heat and do a job with it. And that means there's a furnace or a boiler someplace that's not being used, because we're taking the heat from that exhaust gas and running it through our floors and heating our rooms. Another very good example is on the right side bottom picture. our absorption chiller. An absorption chiller is a phase change device. So again, we deliver it just the 200 to 220 degree hot water. It uses the heat energy only in that water, so we're only running a couple of horsepower pump to keep circulating the hot water through that. And as it passes by the co-located tubes that are full of refrigerant, in this case lithium bromide, it boils the refrigerant. And boiling is a phase change device, and in boiling and condensing, you have a cooling evaporation, and condensing, you have a cooling opportunity. So we literally put into this device 200 degree hot water in one end and get 44 to 47 degree cold water out of the other end. That cold water then is taken back into similar heat exchange devices, and that's how we are able to air condition an injection molding plant with all this thermal energy in it and not go broke trying to pay the utility bill that would be required to air condition that kind of a task. We've upgraded now our newest combined heat and power plant, as I mentioned, through the opportunity from an NYSERDA grant. And now we kept 10 of the original micro turbine generators, as you can see in the center picture there. But we took 15 of the old C30s out and replaced them with 8 new C65s. The C65s are not only the newest, most efficient technology, but they've also changed the opportunities of them. So as you notice, these are the new turbines, and they have a box on co-locator combined on the top of them. You can also see it in this picture. And that's the heat exchanger. So now it's no longer necessary to have this scenario here where we had to take it's right there, right at the highest, most efficient possible place to get the heat energy out and create the hot water that's necessary. And in the back, which you can't see in any of these pictures right now, so 4 of our C65s are like that. 4 of the new ones are shorter than that. We did not have heat exchangers on it. And the reason why is we want all of the hot gas, exhaust gas, to come out of that and go to the blue device in the center of the screen, which is our second absorption chiller. So by this upgrade opportunity, we were able to add double our thermal utilization. And so in the end, this device, 15 years newer technology, takes the hot gas only directly into the machine and gives out the 44 to 47 degree cold water. So we're using heat energy from making our electricity to run the machines to air condition the room that it's in by the wonderful opportunities of absorption chilling. In doing that, we removed 8 natural gas furnaces, 8 5-ton electric DX air conditioning units, and 2 20-ton rooftop electric air conditioning units. They were all recycled and replaced with 12 water-to-air heat exchangers. So we make the hot or the cold water from our exhaust gas and use it to heat or air condition 14,000 additional square feet of space. So now our complete building, our total facility, is able to be run on the thermal energy, the thermal opportunity that comes from burning the natural gas in our microturbine generators. This is a engineer's CAD rendition of how our system is laid out, and another version of if you were a virtual version, like if you were standing in the floor. And this is a real-time website, real-time reporting site that we have. So if you go on HARBEC's website and look under sustainability, you'll be able to look at our energy reporting. And so this slide represents the CHP plant that I just described, the wind turbines that complement them, and then the power that we're getting from the grid, knowing that all that is green power because we buy only green power from the grid. And it's available to the public. It's used for showing that everything is standard units, standard technology. There's no rocket science or special development of any kind. The vendors that provide this kind of serviced and design and implementation for us. All of it is very standard. And then if you want more details about any portion of it, you can click on it and it will give you more in-depth detail and historic perspectives. The other part is our renewable energy. So I mentioned the first wind turbine was a 250 kilowatt machine. We are a class 3 wind site. That means you would not put a wind farm here because it's not robust enough wind potential to cost justify a field full of wind turbines producing wholesale power to the grid, because that's all wind farms can do is sell wholesale to the grid. But we're not using it the same way, so we can afford to have a little less dynamic of a wind site. Specifically, we are displacing retail. So we use the energy that our wind turbine makes before it goes to the grid. So it's in place of grid power, so we're replacing retail. So while wholesale to the grid might be 3 to 4 cents a kilowatt hour, we are displacing 13 to 15 cents a kilowatt hour. So we can afford to have a less dynamic website or wind site, and we're able then to still have a very cost-effective result from it. And in our case, we had we're displacing about 14 to 15 cents, like I mentioned. Our turbine produces 300,000 kilowatt hours of power each year, plus or minus 10%. And so we can count on about an average of $45,000 a year revenue stream, and it paid off then the $400,000 wind turbine project in a little less than 8 years. Again, by taking the energy that it produced, and instead of buying the electrons from the utility, we bought the apparatus from the bank that makes the electrons. And this first turbine allowed us to predict our energy costs for the amount of energy 20 to 25 years into the future, which is, again, a very positive attribute if you're trying to run a business. Then it worked so well that we did the second wind turbine, as I mentioned. Now we went to an 850 kilowatt machine. It's capable of producing 1.5 million kilowatt hours a year. And now we're up to about 50% of our energy is coming from the wind turbine, adding back both wind turbines were in the range of 50 to 60%, all renewable, all predictable energy costs 20 to 25 years into the future. But it's not all of it. And so this turbine will pay for itself in less time, and the reason why it's not proportional to the first wind turbine is because by this time there were grants available. And so in this case, we're showing that grants make it more doable, but they don't depend on it. So the first time we did it, there were no grants. No one had ever heard of it, and it was deemed by most to be kind of foolish. But by the second time, it was becoming widely accepted, and grants were available. So we took advantage of it. And you can see in the end, it knocks about a year or a year and a half off of our payback time. But we still have the same potentials, and we still would have done it with or without the grant because it makes good economic sense either way. For transportation, we try to use the most fuel-efficient vehicles that we possibly can because they make less impact on the environment, and because then the result is we have to buy less carbon offsets or carbon credits. So our fleet consists of the all-electric Tesla, the Prius hybrid, the Hyundai hybrid, and a hybrid diesel-electric international delivery truck. And wherever possible, we use biodiesel in that. So we're trying, wherever we can, to reduce the amount of carbon fuels that are required to move our people from one place to another to run our business correctly. In the world of energy, green energy, and energy awareness, I like to ask people, what is the greenest energy of all forms of energy? What is the greenest energy that we can possibly have? And if you aren't aware of it, the answer is the negawatt. A negawatt is the energy that isn't used. It's not used because it's saved. And so applying that to other parts of our business, as an example, when we are making our buildings. And so in that regard, there's a wonderful organization called LEED, which stands for Leadership in Energy and Environmental Design. They are a great resource that we have used extensively to learn all kinds of ways of, as you produce your building and operate your building, saving energy doing it. And in that regard, from them, we've learned about things like daylight gathering. If you look in the top picture, you see the bright spots on the ceiling. If you look a little bit in front of them, you see the light fixtures. The lights are off. And what's really lighting that room is the sunlight that's coming in through the skylights. We do daylight gathering. We also do radiant in-floor heating. So to heat our facilities, we have in this particular room, as you can see on the floor there before the concrete is poured, 17,000 feet of rubber tubing waiting to be encapsulated into the concrete floor. And then to heat that building, all we do is run the hot water that we take from the exhaust of our microturbines that's made by that, and we are able to heat the building very comfortably and efficiently and have no parts to maintain or fix or change or clean or replace. Also, in the building structure itself, we use structural insulated panels. You can see in the bottom picture, that's a cross-section of a 3-foot wide panel that is tongue and grooved on both ends, silicone sealed, and gives a complete 2 times required R value for building codes, so twice requirement for the wall with no pinch point. So it's a perfect 2x barrier from the concrete blocks to the roof of insulation, and no loss through pinching the insulation like a standard insulating in a metal building would be. And the roof was also double insulated. So wherever possible, we had twice as much insulation. That's much more energy saved. Those are the negawatts that I was talking about. The first lighting upgrade that I mentioned to you happened in 2007. It was actually it cost the company $65,000 to replace our old type fixtures and ballasts and high bay sodium lights and all of that technology that we had with all brand new TA fluorescent tubes. The cost of the project was $65,000, and as a result of it, the quality of light was improved by using fuller spectrum bulbs than the old type bulbs we had. Lighting energy consumed was decreased by 48% on average company-wide. So our portion of our electric bill that went to lighting was cut in half. The actual numbers of that project, the bulbs and the installation of all the ballasts and all of that, I mean, $65,000 project, but a $38,000 a year savings in our electric bill. And a NYSERDA grant for $16,000 and a tax credit by the federal government for $8,000 meant that we had a 1.5 year payback on lighting. So the contractor offered a financing package. All we really had to do was pay the first payment up front of $1,000. And then from there on, every payment was made basically by our energy bill savings. And in a 1.5 years, we paid off this project. The interesting thing is that $38,000 keeps hitting our bottom line every year since 2007. So every year, or 2008.5 when it was paid off, but that positive impact after the payments are paid is still happening to us because we're not paying out that money to buy a lot more electricity to run the old lights. So we did it again in 2014 and 15. Now the LED technology is mature. There are world-class companies that are making it. There are guarantees with the product. And so we went off in that direction. Again, to show you how this project worked, $32,000 total cost this time. We had a 50% RG&E grant because all we had to do is, the reason why this is significantly cheaper is we had the right fixtures now, we just had to change the bulbs. And so less cost project, but still significant. $16,000 back on a 50% grant from RG&E this time. And 1 year payback with the grant. But even again, as I mentioned earlier, if we didn't get the grant, it would have only been 2 years to pay for it. And so that's coming from the $22,000 a year that's being generated by reducing the electric bill again, by the new lighting that was even more efficient than the first time. Again, that $22,000 just keeps hitting the bottom line year after year after year as we go forward. The barrel project that I mentioned earlier, in this case, we took all of our injection molding machines and we wrapped the barrel where the plastic is melted, and they typically operate at 350 to 550 degrees 24 hours a day, and wrapped that barrel in mineral wool. You can see in the second picture there. And the mineral wool is wrapped around the hot barrel, and then around it is wrapped galvanized metal, and then held in place by band clamps. By doing this, we reduced the amount of energy that the molding machine was using for its normal operation by 40%. And in the 40%, it's also converts into 324,000 kilowatt hours a year. And so that's a positive impact again on our bottom line of $44,000 more dollars. So the small amount of money, relatively speaking, to buy the mineral wool and the sheets of galvanized metal and the band clamps is almost insignificant towards the opportunity. Not only do we save the money by using less electricity, but the molding room that was normally having these uninsulated barrels, all that heat energy was leaking out into the room. And so it was increasing our problem with trying to make it a comfortable environment for the employees. And the result was 12 tons of air conditioning load was reduced. So it added up to 12 tons to overcome it, of air conditioning, to overcome the ambient in the room that was created by not having the insulated barrels. So very significant. You can read the SOX and NOx comparable to what I just said in numbers, dollars and cents on the other side, but a dual positive, in two ways, positive improvement to our bottom line, directly and indirectly. The next is industrial efficiencies. Every piece of equipment that we pick, we don't only think about its performance and speed and strength and cleverness and anything else we might want to think about, but we always try to force ourselves to add in energy. And so we're always trying to make decisions based on how does it perform and how does its energy footprint look? How well does it use energy? How efficiently? And so, as an example of that priority, all of our injection molding machines for many years have been 100% electric. We have no hydraulic machines in the company. And the reason why is because an all-electric machine versus a hydraulic machine can save as much as 50% on the energy cost to run the job. So if you can produce the same part, run the same job, and save as much as 50% less energy, it's very, very significant. In the middle pictures there, you see on the left our dryers. These are resistance-type desiccant dryers that are used to keep our material dry for a molding process. Before we did our combined heat and power plant, it was moisture in our material was our single largest cost of quality issues. After we had done it, and to maintain that problematic level, we were still running as many as 25 of these desiccant electric resistance dryers. And once we air conditioned the plant through our combined heat and power opportunity, we reduced it by 75%. So we reduced it to 5 turbines that were able to do the same amount of drying requirements, and the moisture in the material became little or no significant problem. We also, wherever possible, when we have existing pieces of equipment, have changed them out. And especially if they're more than 10 horsepower, we will replace the motors with new motors that have soft starts at the minimum, or inverter drive type systems that will not only ramp up and ramp down, but will offer modulating capabilities. So all of these improve energy performance very, very significantly. Even things like our air compressor, which normally air compressors are operated by slamming them on, waiting till they fill the tank, and then slamming them off again. All that slamming is peaks in your power reporting, so every month you pay, your bill is based on your maximum peaks, and so you want to minimize them as much as possible. And it also is great, more wear and tear on the equipment to keep slamming it on and off all the time. So ramping up, ramping down, modulating like these kinds of air compressors do is a great savings of energy and on equipment life, improvement of equipment life. So all of these things that I've just listed out for you are some of the examples. That is why the eco-economic conclusion about sustainable manufacturing opportunities at our company. We are controlling operating costs, improving competitive pricing, ensuring power reliability. When the power goes down in the neighborhood, we feel really bad about it as we are continuing to work, because it doesn't go down here, and we are allowed, because of our microturbines, we keep going through blackouts and outages. And we provide fixed energy costs. We control part of our cost of doing business, a significant part of our cost of doing business. And we improve operating efficiencies through thermal utilization, like I mentioned about controlling the heat so we don't dump all the heat into the room, and the moisture so we can have better quality plastic parts. So these are a couple examples coming up now of the eco-economic results of this and how it shows out to positively impact our bottom line. In 2008, we were reporting our Green Power Partnership status to the EPA. So every year we tell them how much energy we used for the year, how much of that energy was green, and how much of the green we made or how much we bought. And so as we were reporting, I got the numbers from my controller of our energy uses from 2005 through 2008, and they had gone down. So I naturally thought, as you normally would, he must have missed something because we grew the business during those 3 years, and so he must have just forgot a big section of the bills or something, or years of bills, whatever. And when I went back to pursue that with him, he said, let me check, and he came back in a few minutes, and as he started to say, it dawned on me. What I was witnessing was a summary of energy savings that we had done. And during that period of time, these kinds of things that I just told you about, how they had really impacted our use of energy, even though we were building our business. And the result of it was that we, in 3 years, grew the business and reduced our energy by 1.25 million kilowatt hours a year. And so let's turn that into numbers and see, does that really make a difference in the well-being of a company? Our electrical consumption reduced then by 35%. And we pay, again, between 14 and 15 cents a kilowatt hour. And so that turns into $177,000 of actual money that was saved during that period of time. And, as for the sake of the environment, whoever cares, 919 tons of greenhouse gases that were not emitted into the environment as a result of of those improvements. So to us, the lesson learned is that if you want to make an environmental impact, do it in a way that's economically efficient, and energy efficiency will lead you to saving money. So another way to look at this economic opportunity is in an example where in manufacturing, it's a fact that in our size companies, energy cost is 5 to 6% the cost of doing business. So and if we use an example then of a $10 million a year sales, small manufacturing company, that would mean $500,000 a year in energy costs. 35% energy cost reduction in this kind of a company, and that's what we were at, the size of our company at that time, it meant $175,000 a year to the bottom line. $175,000 positive impact. There are other ways of making that. So if we compare it to the savings versus makings, which another way then is to put new business on our plate. And if, again, I mentioned 5 to 10% in our kind of business is average margins, so that would put that at around a $700,000 potential, that 5%. And for us to go out and get the same amount of work done, to put that same $700,000 positive impact back into the company would be, or $175,000 rather, it would mean that we would have to sell another $2 to $3 million worth of sales per year. So to do the same kind of positive impact of $175,000 on our bottom line in a year, we could do the energy things that I just mentioned to you, or we could go out and sell $2 or $3 million more worth of stuff and do all that work and all that energy and hopefully have it work out the same level of profit that we were hoping for. So I often ask myself, if I have to present these ideas to other manufacturers, name one company that if I offered them a chance to increase their sales by 20 to 30% next year, they wouldn't come up at the end of this and ask me for the way to do that. And I've just showed you a way that we did that by same impact on our bottom line, but in a different way. So the whole thing that you have to be aware of is ROI. And the greatest, most frequent reason I hear about why people are not doing projects like this is because their ROI, their corporate ROI rules won't let them do it. I understand ROI. At our company, we have ROI rules too. If our people want to buy a new injection molding machine or a CNC machine, they know they have to demonstrate to me that it can pay for itself in 3 years or less. But when it comes to energy, we have a different rule. And the reason why is we think of energy money coming from a different pocket. The pocket that we have to watch and have ROI constraints on to buying our equipment and improvements and all of that, we follow a reasonable rule for a small company of 3 years. But where we're going to paying opportunities off that are allowing us to produce energy or displace the need of energy, as long as it is paid for by the energy displacement dollars, so the dollars that I would have sent the utility or the gas company for that energy, then we don't care how long it takes. Of course we do, and of course it's got to be less than, theoretically, just less than the life of the object or the potential that you're buying, but in fact, it is enormously less. And so I've demonstrated paybacks to you here on devices and items that are going to last 20, 30, 40, and more years into the future. So 6, 8, 10 even years, is that bad? Is that a bad ROI decision if you're going to buy something with taking the bill that you had to pay anyways, or we call it the I can't do anything about it anyway pocket? So if we're taking money from our I can't do anything about it anyway pocket, where you've got things like taxes, insurance, rent, they're just are what they are. You don't impact or have chance to impact with changes and improvements. And from that utility part of that pocket, we take the money and instead of paying it to the utility, we pay it to the leaser or the bank. Then we are in fact not restricting ourselves to the 3-year rule. And we look at a completely different set of eyes and therefore are able to do these projects. And in the end, we're taking our energy dollars and buying assets. And the assets produce electrons versus giving the money to the utility and asking them to send us some electrons. At the end, when you have nothing but spent electrons versus an asset. So what's next? In our future, we're working on things like we just completed, literally within the last few weeks, several solar farms or solar gardens, small community solar gardens. One of them is under our newest wind turbine. And these are not HARBEC energy. These are energy that we are providing to the subscribers in the community that want to have green power like HARBEC is doing it. And for whatever reason, they can't put solar or wind on their own house or property. So we do that for them and then sell them the power at less than it costs them to buy power from the grid. So they get green power, fixed cost, less impact. And then we're also getting ready to do an energy storage project at HARBEC. The one piece we have missing is storage. And as a result of that, to having a true microgrid, because that's what we inadvertently have developed over these years, is backup. And the backup has to be in the form of storage so that it can be instantly turned on, just like the grid is. Because now that's the advantage that the grid offers us, is if anything goes down, we still stay on because we're connected to the grid with everything. But there are opportunities and possibilities coming in the future. And more as we look at the intensity of storms and the destruction of infrastructure and grids and all of that, it's more and more valuable to have something that will allow you to survive that and keep going while the rest are in rebuild or repair. So energy storage gives us peak shaving. Currently, our company pays $5,000 to $6,000 a month just in peak charges, peak demand charges. So if we could have our constant energy storage, we could greatly reduce that. Loss of prevented due to interrupted power. It's not uncommon that we'll be growing or CNC machining many hours into the build of a particular part. And if we get a glitch from the grid, we will shut the machine down, which can cost from hundreds to tens of thousands of dollars in lost work. So all of those can be eliminated by a storage system also. And we have dispatchable renewable energy with storage. So we can actually, instead of passing our power to the grid and getting, currently we're getting wholesale for that, we could get store it and use it at full rate. And again, we described that before, a significant economic advantage to it if we were using it later on when we needed it. And the last is demand response revenues. We could actually become a positive to the grid because with this combined system, during the summer when the grid is the weakest and most vulnerable, they ask companies to participate in avoidance. And if we could take all of our load off the grid, that would be at any point that they ask us to and completely run on our own systems, and the battery storage would help us do that. We would greatly help the grid out, and they would pay us for us. There would be another reason, an economic reason for to have a storage system. We're also getting ready to build a new addition, probably in the coming year, and it will provide to us a 20,000 square foot roof. Again, always thinking about where can we have energy opportunities. We plan to put a 500 kilowatt solar system on top of that roof to complement our wind turbines, to reduce the amount of green power that we have to buy from the grid, producing it ourselves, as you've seen demonstrated here, economically, more economically than we can buy the green power from the grid. And other areas that we're working on, we are currently talking to farmers that are interested in doing intensive agriculture. We believe the future is factories and farms side by side, because the biggest waste that we have in factories and manufacturing especially is energy waste. And whether we're wasting the energy up our stack as heat or wasting the energy up the utilities stack as heat, it's still the number one cost of running intensive agriculture systems. So if we are wasting the thing that is another company's greatest need, then we have an opportunity for a tremendous symbiotic relationship. And in the end, energy will be utilized even more completely and wasted significantly less. So some of the opportunities that we're considering and talking with people about are listed here. One thing that we've had in the future is the dream of organic Rankine cycle. We've worked with a company called Energy Rotors for a number of years now as they continue to develop better and better products where we're using some more of this heat that's in the water that comes from our exhaust, And then you can see in this picture here a good example of it. This is the organic Rankine cycle device. This is one bank of our microturbines. The microturbine exhaust gas goes through these exhaust pipes, insulated very carefully to make sure that they don't let the heat out, and are taken into a heat exchanger in the center. It's a tortuous path of baffles that has tubing running through the baffles and water running through the tubing. And as the exhaust gas traverses through the baffles, it leaves its heat energy in the water. And now we deliver that hot water to different jobs around the company and do the heating, the in-floor heating, the cooling through the absorption chilling, and as I mentioned earlier, and on top of that, we are able with the organic Rankine cycle to, before we do those jobs, take a little bit of the heat out of the water. So these are all the numbers here, and you can look at them at your leisure. But in the end, by just taking the hot water and energy in the hot water at the 220 approximate degree hot water, and we were able to run this device and get 5 kilowatts of electricity out of it. The resulting water was only dropped down a few degrees, as you can see there. So still the majority of the heat energy was in the water to do all the rest of the jobs that we normally do. So no impact was made on those jobs that we needed to count on the heat for. But 5 kilowatts of electricity was made, and this is a small one. They now have machines of this type, this company, and probably even bigger since I last checked with them, of at least 30 kilowatts, and on and on. So this is a way of using the heat energy that's in a different way to make electricity, to take an advantage of that thermal. Beyond that, there are dreams and plans and actual events happening around building a sustainable industrial park. And our definition of that, our concept of that is that it is focused around energy, because energy is such a significant part of manufacturing. And so you can see in the example on the left how currently our first phase of our Wayne Industrial Sustainability Park is set up. Out of the HARBEC generating plant, we are powering 4 other buildings and heating 4 other buildings. So we take the heat and the hot water and our electricity and deliver them through connections to all these other buildings to do heating and electrification in their companies and facilities. The result of that is that all of the greenness that I just talked about, all of the carbon neutralness of what I just talked about, is passed on to these companies, because buying the power from HARBEC gives them the same advantage and the same carbon neutral because of their choices. They only have to be responsible for their vehicles beyond that. And so this is working very well, and another positive opportunity has happened. It is no longer necessary to put the copper in the ground to connect these buildings. You can do it virtually through the grid system. So this model becomes even more dynamic, more possible. And so behind me, you can see the examples of where our plans are to go next. So we are, again, coming from HARBEC, doing these 4 buildings. And next, we have interested parties, a 10,000-foot plumbing contracting, 25,000-foot precision machine building company, and perhaps even precision optics, on and on and on. So we sit on the edge of an industrial park that is ripe for this kind of opportunity, where we can deliver heat to them through basically a district heat loop, which is an old concept just being rebirthed, and or through power from our generators. And again, that's being able to be done now by what's called remote net metering in New York State. We also do the same things that we just talked about as for our carbon neutral and water neutral. Unfortunately for us, we live in the Northeast, on the greatest source of fresh water in the world. And so water for us is very cheap. So I can't make the same eco-economic examples for water. But we believe that water is very, very important, and that many other parts of the world are not as fortunate for us. And so we've taken on ourselves the responsibility for all potable water that we consume in our company, and wherever there are places where they're used inefficiently or ineffectively, we are replacing them either with water we capture by rainwater harvesting our roof and parking areas into the pond that you can see in the picture on the left, and or using that same pond as a thermal opportunity through heat transfers and different opportunities that can provide. And so in 2015, we became water neutral, and that is a result of doing constant reduction in water consumption, city water consumption, and wherever we can't, once again, we buy water credits and pay someone else to help us and take care of certain numbers of gallons of water offsets. Also, in the area of sustainability, we can't do anything about the materials that we use because they're determined by our customers. So the polymers historically have been all fossil origined, but there's a great movement currently in bio-origin, so plants and other sources of oils and sugars in nature, where they can be replaced by growing a new crop of them. So we are doing everything we can to support the efforts in the bio-origin polymer world. We've made a website about it. We have offered any biopolymer producer free service where we will take their material, process it, and then return parts that show examples and all the processing parameters that we did through design of experiment to get their material to process correctly. And that's it. So for the last hour or so, I've been telling you about HARBEC's conviction to eco-economic sustainable manufacturing. At HARBEC, we regard eco-economic sustainability as absolutely critical to the future of our business, and we believe that the success in pursuit of it will improve our competitive advantage by ensuring our efficiency. So you can see some of the awards and accomplishments that we've gotten, and I'll leave you then with one final slide to think about and open it up to if there are any questions.
Why aren't more companies doing the same things HARBEC's doing to, better the environment and better their own business?
I think if I was to guess, the biggest reason why is because, as I mentioned earlier, the ROI mindset. The conventional company, if you go to business school, you're going to learn all about the importance of ROI. And in Fortune 500 companies, it's typically 1 to 2 years. And smaller companies like us, it's 2 to 3 years. But everyone has this barrier that's put up to help make sure they control their expenditures wisely. And so the good news, though, is that it's starting to change. And I'm very optimistic. And the biggest thing that I think that is helping that to change is the ISO standard that I was mentioning before. ISO 50001 SEP, and I believe is the real changer, is demonstrating, and you can go on their website, and it's an amazing collection of every month increasing new case studies of major companies around the world who are saving millions and millions of dollars by doing this. So the mindset has been, don't pay attention to it. It's for so many people in my life, as an example, I say, why do you worry about it? Just plug it in. Well, there's money to be made. If you want to worry about it, if you want to make it a part of your responsibility in operating your business, there's great opportunity, economic opportunity in it. And so I think if more and more companies would just, don't believe me, go to DOE, ISO 50001 SEP, and look at the examples that they're presenting. In only a few years of time, I think the standard is only maybe 3 or at the most 4 years old, and begin to get an appreciation for the hundreds of millions of dollars that are being saved yearly. And if you just think about the dollars, that's a good enough reason to do it. But if people more and more become aware of social responsibility, then all those dollars represent negative impact on the environment that didn't happen. Dumping into the environment that didn't happen. That's it.